Hello, everyone. After mastering the structural requirements for reinforced concrete strip foundations under walls, we will now move on to another common form of strip foundation, reinforced concrete strip foundations beneath columns. By the end of this lesson, you should be familiar with the structural requirements for this type of foundation. Just like the structural requirements for reinforced concrete strip foundations beneath walls, the construction of reinforced concrete strip foundations beneath columns must also comply with relevant codes and standards. Likewise, every design parameter must be selected with a clear and justified basis in order to ensure both the quality and safety of the project. The design of these foundations primarily follows national design codes and applicable local standards. So, how do the structural requirements of column-based strip foundations differ from or resemble those of wall-based strip foundations? Let's find out together. Column-based reinforced concrete strip foundations generally adopt an inverted trapezoidal cross-section composed of rib beams and wing slabs, as shown in the diagram. In addition to meeting the structural requirements previously studied for reinforced concrete strip foundations beneath walls, it must also satisfy the following additional requirements. 1. The height of the foundation beam should preferably be 1/8 to 1/4 of the column spacing. The thickness of the wing slab shall not be less than 200 mm. If the wing slab thickness exceeds 250 mm, a variable thickness slab is recommended, with a maximum slope of 1 to 3. 2. The ends of the strip foundation should generally not extend outward. The length of the foundation beam should be approximately 1/4 of the first span. The primary purpose is to increase the bearing area of the foundation base. In addition, to ensure that the resultant force of the superstructure load aligns with the centroid of the foundation, the extension length may be adjusted accordingly to achieve a more rational distribution of the resultant force at the base, as illustrated in point A. 3. The longitudinal bottom reinforcement and the top longitudinal distribution. Reinforcement of the foundation beam shall both comply with the structural calculations. The top reinforcement must be fully continuous, as shown in point B. The area of bottom longitudinal bars should not be less than 1/3 of the total area of the calculated tensile reinforcement. 4. At the junction between the column and the strip foundation beam, the plan dimensions should not be less than those specified in point C. Specifically, the plan dimensions of the foundation beam should be greater than those of the column, and the distance from the edge of the column to the edge of the foundation beam shall be no less than 50 mm. 5. The concrete strength grade for the column-based strip foundation shall not be lower than C20. 6. The transverse reinforcement of the wing slab shall be determined through structural analysis, but the diameter must not be less than 10 mm, and the spacing should be between 100 to 200 mm. in non-rib areas. Longitudinal distribution bars may have diameters of 10 to 12 millimeters, with spacing not exceeding 300 millimeters. 7. The stirrups in the foundation beam shall be of the closed-loop type, with diameters generally between 8 to 10 millimeters for beams with a depth exceeding 800 millimeters. Stirrups shall not be less than 8 millimeters in diameter. Stirrup spacing shall be determined based on relevant structural codes. For beams with width less than or equal to 350 millimeters, use double-legged stirrups. For width greater than 350 millimeters and less than or equal to 800 millimeters, use four-legged stirrups. For widths greater than 800 millimeters, use six-legged stirrups. These are the primary structural requirements for reinforced concrete strip foundations beneath columns. As with wall-based foundations, the design of column-based strip foundations must also strictly adhere to applicable standards and specifications. Let me emphasize once again. In engineering construction, we must cultivate a strong awareness of standards, remain dedicated to our profession, and practice with integrity. Even minor oversights may lead to serious safety incidents. That wraps up today's lecture. I hope you found it informative and beneficial. Thank you all.